If you're watching this, you are taking a look at the 4.5 Desmos lab. I hope you're having a great day. I know that we're just getting through some snow over here on February 8th, but I'm glad you're here and I'm glad you're paying attention to this and maybe even taking a few notes. Nothing wrong with that. 4.5 has us working with Elvira again in the cafeteria. We said Elvira is kind of a weirdo, but in this case, we are applying the properties of inequalities to solve inequalities. So imagine that we're using properties and we're solving said inequalities. Take a moment, pause the video, read through this once, and we'll come back and highlight the important bits. So you should have read through this problem once. Elvira's in this cafeteria with cute little milk cartons that are typical of school lunch. The milk supplier charges 35 cents per carton of milk, in addition to a delivery charge of $75. So that would be a one-time fee of $75. And the main question we're being asked is, what's the maximum number of milk cartons that Elvira can buy if she has budgeted $500 for milk? All right, sounds good. Write and solve an inequality that models the situation to the right. Well, the delivery charge, how many times do you think we have to pay this? Hopefully you're saying this is just a one-time fee. So we have the delivery charge, which is $75, and our order should continue to add on 35 cents per carton of milk, which I'll denote as X. What do you think? Should this be greater than $500, less than $500? What do you think about that? Hopefully you're saying less than or equal to $500 because this is the maximum number we can buy with $500. We don't want to buy more and have it be more than $500. We want it to be as close to 500 as possible. So 500 is the max. Describe in words the quantities that would work in this situation. We have the delivery charge. I'll put parentheses around this. The delivery charge plus price per carton. That's multiplying with the quantity of cartons. And we're saying that should be, and I'll put parentheses around these individual bits. Saying that that should be less than or equal to the maximum amount budgeted. There you go. We have the inequality there. We'll take this apart and solve it in a second. So our delivery charge again was $75. We're adding on 0.35 times X, where X is the quantity of cartons that we're buying. And we're saying this should be less than or equal to 500. So luckily we can solve this with the two-step equation. So just add method up. We can get rid of 75 by subtracting from here and here. That leaves us with 0.35x is less than or equal to 425. What can we do from here? Hopefully you're saying divide by 0.35. Let your calculator take care of this and maybe think out, do we have to switch the sign here? Get a calculator, solve that, and think out, do we have to switch the sign? So you don't have to switch the sign, but you should have said that X, in this case, the number of cartons is going to be less than or equal to 1,214.29 cartons. So think, are we able to buy 1215 cartons or 1214? So 1215 or 1214, which one makes more sense? Hopefully you're saying that we can buy anything up to 1,214 cartons. And so we're given some options here on how to write this. For interval notation that uses brackets, that uses parentheses, we could buy 0 cartons, but we definitely want to note on everything between 0 and 1,214. So that's what's happening there. I'm going to actually exclude that comma there because I don't want it to throw you off and make you think that it's 0, then 1, then 214. Okay. The set notation, you could say that in between 0 and 1,214, that's what you can get. And again, we're dealing cartons here. So we could get 1,000 cartons, 1,100 cartons. Those are all fair game in this case for the budget. Take a moment, pause, try this whole thing out, and I'll talk through it all in a second. I've got everything here that I think you need. Elvira has to deal now with the amount of ranch that's left over. Sorry about that. And so this is all based around 130 gallons and then deducting 2.25 versions of it. So I have 130, I'm deducting 2.5x. And since we need at least 20 gallons left, all of this needs to be greater than or equal to 20. If you solve this, again, two-step inequality, you're subtracting at first and then dividing. Pivotal thing here, please note, is that when you're dividing, notice you're dividing by a negative number, so you're switching. Please make a note of that. So notice the switch. That's a big deal. Eventually, if you solve this, you're going to say that x is less than or equal to 48.889. I think I just had it here, but we want to round down to 48 days because if we go to 49, we're going to run out. Also, if we exceed, pretty much if we exceed 48, we're going to be out of range at the middle of the day or so, or in this case, 8/10 of the day, or 89% of the day. I don't know. I don't want to get too crazy with it. Our interval notation is going to use brackets from 0 to 48. Our set notation is bounding between 0, less than or equal to x, less than or equal to 48. So it's kind of saying the same thing there. They could be equal to 48. They could be equal to 0. But if we're trying to retain at least 20 gallons, it's got to be in between those two days. Hope that helps. Take a moment, try the next one. So pause the video, read through the problem, try it out. I'll highlight what's important. All right, so we're dealing now with an average. We've seen one of these before when we were taking the average of the first 3 baseball games. So we have Elvira trying to buy veggie burgers. She's done this 4 times and has paid $78, $72, $87, and $90. To stay within her budget, Elvira needs to be sure that the average order, so average is a big deal here. We haven't had to deal with that too much, but it should ring a bell. The average order is not more than $82. So this is actually a big deal. I want to highlight on it. Since it's saying not more, it's saying that it can't necessarily be equal to $82. It should just be less than. So the whole order average should be less than 82. How much can she spend on the 5th order? Well, we have the 1st, the 2nd, the 3rd, the 4th set of orders with their currencies. This X I'm denoting as the price of the 5th order. And again, if we take the average of all 5, it should be less than 82. So if you add up these 4 numbers, these are the 4 orders that have a number attached to it. If you add them all up, it gets you 327. If you multiply both sides by 5, that breaks up the fraction. You can then subtract 327, and this leaves you with the 5th order should be less than $83. So as long as the order is less than $83, the average will be less than $82. Since Elvira might get a refund on the order, it could turn out to be less than 0. But in this context, we want to talk about an actual price. Like a distributor is never going to charge you -$3 for something unless they're giving you a credit. But in this case, you're just starting at 0. So your interval notation would start at 0, go to 83, and potentially, well, yeah, I'm going to have it just not quite get to 83. So this is your interval notation. Your set notation is going to look like this. 0 less than or equal to P. Again, this is the price. So I'll call that the price, and that's less than or equal. No, not less than 83. There we go. Boom, there you go. Kind of like this one. Elvira has the option to purchase ready-made pizzas like Elio's or something you would bake at home, but Elio's I think is the top one. However, if Elvira makes them in the cafeteria, she can spend $44.20 on ingredients and $6.25 per pizza on labor. So as a quick sketch, there's the option to use the oven. So the oven pizza, it's got knobs on it. So it's really coming down to, do we want to buy something that's already ready-made? Or maybe actually this will be the ready-made. It's already kind of put together. This is the ready-made, or do we want to use the oven? Which one's it going to be to do? That's really what we're contemplating here. So how can we compare these two options? Well, I know that the one price is $14.50, and that's per pizza. And I'm curious what the equivalency is going to be, because if we do just a flat sell on $44.20, but then we keep adding on $6.25, like, when does it make sense to do one, maybe not the other? Take some time, try to solve this one. So what's this saying? This is saying that if the number of pizzas made exceeds 5.35, so pretty much if we're making more than 6 pizzas, it's going to be cheaper in the cafeteria. So let's make a note of that. If we're making more than 6 pizzas, it's cheaper to make them in the cafeteria. So as far as the interval notation, this would actually start at 6 and then go to infinity. We want to use bracket parentheses on that because we can't necessarily get something to equal infinity. We do the same kind of thing here. So 6 is less than or equal to x, but then it's less than infinity. Something like that could work. You could also say that just x is greater than or equal to 6. Something like that's fine on its own. If you want to say it's less than infinity, you could do that too. But honestly, you could just put 6 is less than or equal to x, and that works just fine. If you read through this, you're comparing 2 different suppliers of fresh lettuce. I'm sure that's a heated competition. You have Val's Veggies charging $250 for delivery, so that's a one-time fee. Then you have $1.50 per bag of lettuce, and that can vary. We might only want 1 bag. Sometimes we need more. And we're comparing this to Sally's Salads, which is charging $100 for delivery plus $4 per bag of lettuce. How many bags of lettuce must be purchased for Val's veggie options to be the cheaper option, so less than Sally's? If you set up this inequality correctly, it would look something like this. Take a moment, try to solve this, try to move x terms to one side, constants to the other. We'll touch base in a second. This is saying that if you are making more than 60 pies, Val's is going to be cheaper. You could have done this all in like one step where you're moving x terms to the right and constants to the left. So notice how I'm only left with x on the right, constants on the left. Eventually, if you divide both sides by 2.5, that gets you 60 is less than x. So what's this all saying is that if we make Val's will be cheaper if we make more than, or rather buy, if we buy more than 60 bags of lettuce. There you go. As far as the notation for this, you could say that you're starting at 60, that's going to infinity. So again, making more than 60, which is, yeah, that's fine. You then have 60 as your bottom bit, that's less than x. So this is the interval notation. This is the set notation. There you go. Last one. I'm so proud of you for staying with us. They have each student buying school lunch, paying $275. Cafeteria typically brings in between $1,168.75 and $1,438.25. How many students does the cafeteria usually serve? Well, it's between those ranges of the 1,168 and then the 1,438. So it's kind of bound between these two numbers. That's where all the action is. And I'm leaving some space here because we're soon going to fill it in. But how do you think the lunch, how much students pay per lunch? How do you think that changes things up? What do you think? How can we bring that in? Well, you could say that it's in between those two values. So it should be 2.75 multiplying X, where X is the number of students. So how can we take this further? We could divide all of these terms by X. No, it's like by 2.75. Which is totally okay, because if we do it to the middle, we do it to the left and the right, X cancels. We're then left with X being less than 523 and greater than $424. It's like 424 people, 0.73. Yeah. So it's in between those amounts. We could have also simplified this and said, since we don't want a fraction of a person, we could say 425 less than X less than 523. So it's in between those two values. As far as interval notation, parentheses it up from 425 to 523. So that's the interval notation. For set notation, you have 425 less than X, which is less than 523. And again, we're talking students here, so that's a big deal. So students. And again, we don't want the fraction of a 424th student, so that's why we rounded up to 425. I hope that makes sense. If you have any questions, reach out. Hope this was helpful. Thanks for watching.